Okay, then we're going to have a discussion on diffusion and the factors that affect diffusion. By definition, we say that diffusion is the movement of particles down their concentration gradient. Physiologically, what that means to us is there is a membrane that is going to separate two bodies of water, and that particles in those bodies of water will be able to move across those membranes in order for diffusion to occur. The coefficient of diffusion is something that we talk about as being a number that represents the overall ability of the particle based on its chemistry, based on its size, based on its interaction with the membrane, to be able to go through the membrane. If for whatever reason the membrane doesn't have the number of pores available, or the pores are not the right size, then the coefficient would be very low or non-existent. On the other hand, if the coefficient is high because there's a lot of particle channels available for that particular solute given that membrane, then we would see a rise in coefficient and therefore a rise in diffusion. Now, the movement of particles going down their concentration gradient automatically makes the concentration gradient, the difference between concentration in A compared to B, or concentration of 1 compared to 2, however you want to look at it, that is a big factor. Particles are going to move downhill, so to speak. So if you're talking about a particle, let's say a solute particle, it is going to move in this direction from A to B as written. The amount of diffusion that is going to occur, or I should say the rate of diffusion that is going to occur, is going to be affected considerably by the concentration gradient. If the concentration gradient is low, then you're not going to have as much diffusion. If the concentration gradient is high, meaning that there's a lot more particle to make up a concentration level in A compared to B, then you would expect to see a lot of diffusion going across the membrane. If the concentration gradient were essentially non-existent, in one sense we say that when the concentration 1 over concentration 2 equals 1, you really don't have a concentration gradient set up anymore. What you've got is equilibrium, and the particles, while they will move back and forth, because you cannot say that diffusion ceases to exist, the net diffusion, on the other hand, will now be 0, because the number of particles moving this way at any given time is equal to the number of particles moving that way at any given time. Now, another factor that affects the rate of diffusion is the area of the membrane. Compare this area in the square here. The orange square represents the membrane that's allowing for diffusion of solid particle, compared to this area where only the little circle, orange circle, is allowing for the particles to go through. So given that the coefficient is the same, let's say, so the density of the available channels for the diffusion of these particles is the same, the fact that you've got so much more area here compared to here will automatically allow more diffusion to occur in this scenario compared to this scenario. And lastly, we talk about something that's referred to as the thickness of the membrane. Obviously, a membrane that is thinner is going to make it easier for the particles to go through compared to a membrane that has considerable thickness, where even though, let's say, the number of channels or pores available are the same, the particle has to move through the entire thickness of the membrane, which would then somewhat slow down diffusion. So in conclusion, we say that by the so-called Fick's law of diffusion, the rate of diffusion is dependent on the following factors. Directly proportional is diffusion to the concentration gradient, the coefficient of diffusion, and the area of the membrane. And at the same time, the rate of diffusion is inversely proportional to the thickness of the given membrane. This concludes our discussion of factors of diffusion.